So now that we've practiced drawing some Venn diagrams and making sure we understand set notation by using those set cards, we're going to do some examples to truly understand how to calculate some of these probabilities and to practice drawing the Venn diagrams. So in this first example, we're looking at taking a sample of 150 NKU students. We're trying to see if they support two of the Democratic candidates that are going after being the party's nomination for this election, Biden and Warren. From our sample, we found that 89 support Biden, 33 support both Biden and Warren, and 18 do not support either candidate. So we're going to first start by drawing the diagram. So we're going to start by drawing our entire box, which is of course our sample space that we're going to be working with. Since we're talking about two events, Biden and Warren, we're going to have two circles that we're working with. I'm going to draw them in different colors to make our life a little bit easier. So I'm going to let the green be my Biden circle and my blue be my Warren circle. Now I'm going to start by making sure I truly understand what these numbers are. So when I see this 89 support Biden, that's going to be the entire green circle, which means it's going to include both this piece and this piece. So right now I can't put that 89 on my picture because I'm not sure what number is here versus here yet. I now know also that 33 support both Biden and Warren. Well, where do they support both Biden and Warren is on this inside piece there. So I now know that that is the 33 that was being given to me. Now I can backtrack and use this 89. Because again, this entire circle needs to be 89. So to find my number I want to put there, if I take my 89 minus that 33, I will get 56 to be in that piece, because now when I look at my entire circle, 89 support Biden. We're also given that 18 do not support either candidate. So they don't support either Biden or Warren. So that means that 18 is on the outside for me because they're not going to be in either circle that we're looking at. So if I look at my picture now, there's only one number I don't know, and that's this piece on the outside for my blue Warren circle. But here's what I also know. There's a total of 150 students. So if I take my 150 and subtract off all those numbers I already have, so subtract off my 33, subtract off my 56, and subtract off my 18, we'll find that that's going to have to be 43 people that are in that piece for me to have my total of 150 NKU students. So I would make sure at this point you feel okay with where I got each of those numbers. Because notice the 89 you don't see directly on there. It's showing up in those two pieces being added together. Now that we have the picture, some of these probabilities might be easy to calculate. So we want to first find what is the probability that one of these students support Warren. Well, one of these students tells me that I'm talking about one of the 150 students that I'm working with. So that's going to be my bottom number. Well, how many of them support Warren? This is where, again, we need to be careful. Warren is the entire blue circle. So I need that 43 and the 33 piece. So that will then give me 76 out of 150 of them will support Warren. One of the other things we want to practice in this video is understanding what notation that probability I found is. So this is finding just the probability that someone supports Warren. But again, please make sure you're writing down this notation because trying to understand what the problem's asking and getting yourself used to that notation. Next, we want to find the probability that one of these students does not support either candidate. So again, we're starting with just one of these students. So that means I'm going to start with the 150 on the bottom. Now, how many don't support either candidate? Well, that's actually one of the numbers that was given to me in the problem. That's just that 18 that we have. So I'm hoping that calculation isn't complicated. Now actually figuring out that notation might be a little bit more complicated, because I don't want to be in either circle. So I'm going to first think about, well, what would it mean to be in at least one of the circles? Well, if I was looking at wanting to support at least one of the candidates, that's that union that we've talked about. So if I look at where Warren union Biden is, that would be all of these numbers together. Because that's going to be you support one candidate, the other candidate, or both candidates. So it's going to include all of that. Well, that's what I don't want. So if I actually take then the complement of that, that is actually what I'm finding, is the complement of the union. So that is what I just found the probability of, was W union B complement. See, it gets a little bit more complicated. But again, just trying to understand that notation is very helpful, I think, at this point as well. Next, we want to find the probability that one of these students supports at least one of these candidates. So, again, we're starting with just one of these students. So we're going to be dividing by the 150. Now, what I want then is a number that supports at least one. That's in a sense the opposite of what I just found. So I kind of want to add these three numbers together, and that's going to give me my top value. So I'm going to get 132 out of 150. Notation-wise, what did I just find? Well, I just found the probability of Warren union Biden. But now it might also be useful to look at some of those rules that we talked about. All right, so I'm going to be using general rules, and I actually have one of how to find the union. I'm going to take the probability of the one plus the probability of the other and subtract off their intersection. Let's see if we can see how that rule would actually apply to what we did here. So how I would also be able to find this value is take the probability of Warren plus the probability of Biden and subtract off their intersection. Well, the probability that someone supports Warren, we just found up here. So that's going to be our 76 out of 150. We're going to add to that the probability that someone supports Biden, which again is that entire Biden circle, or is that 89 that was given to us originally. But then when I've actually done that calculation, I've counted this 33 twice. I counted it in my Warren circle and I counted it in my Biden circle. So that's why we're going to subtract off that intersection of the 33 out of 150. And once you do that math, you're going to get the same thing of the 132 out of the 150. Again, you might not actually have to use the rule if you can just use the picture to get that, but I just wanted to show you how that rule actually would apply to the problem as well. Next, we want to find the probability that a student who supports Biden also supports Warren. This one's phrased a little bit different. We're not talking now about just any of these students. We're talking about a student who supports Biden. Well, how many students supported Biden? There were 89 of those to begin with, right? I can see that here in the problem, or look at my picture to see, well, there was 89 students then who support Biden. Now we want to find, well, the number of those 89 students who also support Warren. Well, if I look at where I am of these 89 students, how many of them support Warren? Well, it's just that 33 that I see. So it's just going to be 33 out of the 89. Again, how this is different. Above, just one of these students, one of these students, one of these students. And every time I saw that, I had 150 on the bottom. But now we're not just talking about one of these students. We're talking about a student who supports Biden. So I can't use that entire 150. I only have 89 students who supported Biden. Now, how do I write this notation-wise? Well, as soon as now I've started with a different group, I'm not starting with all 150 students. This is what makes this a conditional probability. So I already knew that the person supported Biden. So that's what I already know. Then I wanted to find the probability they support Warren. So notation-wise, this is the probability that someone supports Warren given they support Biden. Let's see how the next one is similar but different. What is the probability that a student who supports Warren also supports Biden? So what's different? I'm now starting with people that already support Warren, which is different. How many people supported Warren? Right, the 43 plus that 33, this 76 that we found up in Part A. So that's going to be my bottom number. Now, of those who support Warren, so my blue circle, how many of them also support Biden? That 33. So what's different about these two calculations? It's what we already knew about someone. This time we knew they supported Warren and wanted to find the probability that they support Biden as well. All right, finally for Part F, we want to see if supporting of these two candidates is independent of each other, why or why not. Now when we're talking about independence, what we can do is go back to this pretty little table that we had, and there's an independent column. Which this means is if two events are independent, this will be true, and this will be true. So if I just pick one of these rules, if these two things equal each other, then they are independent. If they do not equal each other, then they are not independent. So I'm going to start by just choosing one of these rules. Technically, you could choose any of them that you got. The easiest one generally for students to use is either the intersection or the conditional one. I like the conditional one the most because I think it truly tells you what independence means. It tells you that given you know something, that's not affecting the probability at all. So the one is totally unrelated to the other. In a sense, since I've already done some of those calculations, this is also going to be my easiest one to use here. So if they are independent, here is what we know. If they're independent, the probability of supporting Warren, given you also support Biden, should be equal to just the probability of supporting Warren. Now, why did I choose this rule? I've already done this calculation. I've already done this calculation. So I don't have to do any extra math. I already have these numbers. So this means that I'm going to check is our 33 out of 89 the same thing as our 76 out of 150. Now, it might be hard to tell by just looking at the fractions, so this is where changing them to decimals could be helpful for you. So the 33 out of 89 is 0.3708. And the 76 out of 150 is 0.5067. So do those two things equal each other? No. So if they're not equal, they are not independent. So there's one example doing a Venn diagram. On the next page here, there's a second example. So what, again, I would recommend doing is pausing the video here, try this one as much as you can on your own, and then see if our answers match. And I'm actually going to pause it and work part of the problem so that we can talk through it. All right, so I've first drawn my picture. So math and English are my two different events. We have a total of 200 students. That should be useful. 184 to get at least one of those two courses. So that's the red and purples all together. So even though that number doesn't tell me a lot, it does actually tell me something. Because if I take my 200 and subtract off that 184, that means there are 16 students who didn't take either course, which means they are on the outside. Now, 96 took both courses, so that's that intersection, so we're in the middle of them. And 160 took an English course. So again, that 160 is going to be that entire purple circle. So I'm going to take the 160 minus the 96 to give me that 64 is in this piece of my circle. Finally, my entire picture should add up to 200 people. So if I do my math there, I should be left with 24 students in this piece. How did you do on the picture? Okay, now that hopefully you have the right picture, we can now try to calculate these probabilities. So again, if you haven't already, pause the video here, try them, and then you can always come back and watch the video to see how you did. All right, so let's see how we did first on doing the math attached to the ones that asked for a probability. Part A, we wanted to find the probability that one of these students, so my 200's on the bottom, took only a math course. So they didn't take an English course as well, they just took a math course. So that's going to be that 24 that I have there. Now notation-wise, technically what we just found, a lot of times we want to label as that you just found the probability of a math course, but we didn't, because that's the entire red circle. So that's not what I found. I found that and subtracted off that intersection of where they took both courses. So notation-wise, that's really what we just found. In part B, we want to find probably that one of these students, so again 200 on the bottom, didn't take either course. So that's our number on the outside. This is similar to the one that we found in the previous example. So this is where we found the complement of the union. So if we take the union of the math and English courses and took its complement, that's what we just found notation-wise. Now part C, we found the probability that one of these students, so 200, took a math course. So notice how this one's different than part A. Took only a math course versus took a math course. So this includes those that took a math course and possibly an English course at the same time. So I have to add those two pieces together to get me the 120. Now what we did then just find notation-wise is the probability of just taking a math course. All right, D is where things got a little bit different. We found the probability that a student who took a math course. Well, so how many students took a math course? Again, entire red circle, so 120 on the bottom. Of those students, how many also took an English course? That 96. Notation-wise, this is one of those conditional probabilities. Now that I no longer have that 200 on the bottom. What did we already know about this student? Well, we know that they took a math course, and we're trying to find the probability that they also took an English course. Now in E, we found the probability that a student who took an English course, well, so I started with those 160 students who took an English course. How many of those also took a math course? The 96. So again, notation-wise of what we just found is the probability of having taken a math course if you had already taken an English course. So how did you do on the calculations? All right, finally, we're checking to see if taking these courses are independent or dependent events, and we're going to show and explain. So again, we're going to use one of those rules. Just as before, I'm going to use the same rule of checking to see is my conditional probability the same thing as the one that I already know. So again, notice that these are the letters that match that we're checking. Again, I chose these because I've already done these calculations. So my probability of math given English was 196 out of 160 students. I want to see, well, is that the same as the probability of just taking a math course, which we already have above as well in Part C. Again, might be hard to see without actually doing the decimals attached to this. This is 60%. And this is also 60%. So do they equal? Yes, they're equal. So since they are equal, these events are independent. What that means then is that taking an English course does not affect your probability of taking a math course. All right, so at this point, hopefully you feel ready to do some Venn diagrams and do your homework and all those fun things as well.